Hello again and welcome back to our video tutorial series. In this tutorial I will show you how to build a ordinal marketplace using React and how to make ordinals interact with sCrypt. So in this particular example we're gonna build a marketplace, and each item listed in this marketplace is gonna be locked using a smart contract called ordinal lock. And that smart contract will actually enforce that, once the listing can only be unlocked by either providing the required funds, or it can also be cancelled by the seller. So this is the ordinal marketplace application that we're gonna build in this video. So let us just click connect. It will automatically prompt the Find the Wallet extension of your Chrome browser. So the nice thing about this wallet is it supports testnet and it supports ordinal tokens. And the most important thing, of course, it can be easily integrated into an sCrypt application. So now if we take a look at the layout of the application, we have two tabs. The first one is called My NFTs, and it's basically just a list of the tokens that you have in your wallet. And the second tab will be the marketplace, and here will be listed the NFTs that are for sale. And because this is running locally, we don't have any listed yet. So let us try to list one, this for example, and we put in a price and hit confirm. And this will prompt us the Panda wallet, put in our wallet's password and hit sign the transaction. This will sign and broadcast the locking contract for the marketplace, and it should appear here. So other users, if they take a look at this, they will see a buy button and they will be able to purchase this NFT and it will appear in their wallet. The seller of the NFT will also have a cancel option, which they can use to withdraw the listing. So if we try that, again, it will prompt us for the password and just hit sign. And it disappears from the marketplace and it will appear again in our wallet. And of course, this will all be reflected in our actual extension in this list here. Alright, so let us start building the application. So again, we're just gonna start by creating a blank React project. So we will run npx create React app, and let's just call it Ordinals marketplace. And of course, it's gonna be a TypeScript application. Once it's finished, we can switch directories into the project and initialize Git. We just create a initial commit. There we go. And then we can run the sCrypt CLI and call the initialized command. Okay, so let us open the project now in a code editor. Go. Now, as we can observe, the initialize command will populate obviously the React project with a sample contract, but we won't need that. So let us remove the content of it. And now let us get the actual contract code. So the contract that we will use is called an ordinal lock, and it's pretty much a standard contract that is used across like Ordinals wallet on BSV on marketplaces. And what it does, it just basically lets your ordinal be unlocked if someone pays the specified amount. I already have the URL in my clipboard, so let me just paste it. And you won't have to go to this URL since I will post the link to the finished project in the video's description, so you can just grab it from there. Okay, so let me just copy this code then. And paste it in here. And let me adjust this import. And as you can see, this requires a package named sCrypt-ord. And what this package is it's basically just extension SDK that lets you deal with the combination of sCrypt and ordinals more easily. So in this particular example, you can see that the ordinal lock contract doesn't extend the base smart contract class, but it extends a class named ordinal NFT. And this is just like a regular smart contract, but under the hood, it can handle stuff like, ordinal inscriptions, and in the case of fungible tokens, it can handle amounts and stuff like that. So let us go back to the console and install this package. So we do npm install, and it's sCrypt-ord. Okay, so now if we go back to the code editor, the errors should disappear. Okay, great. Now let us go ahead and compile this contract. So we'll run npx sCrypt CLI compile. Okay, great. Now let's go back to the code editor, open the index.tsx file. And in here, we're gonna load the artifact of the smart contract. So let us first import the smart contract class itself. So it's called ordinal lock, and we're gonna import it from contract folder, and the file is called ordinal marketplace. Okay, now the artifact itself, so it's called artifact from artifacts and ordinal marketplace.json. Okay, and now just load this artifact. So we're gonna do ordinal lock.load artifact, and we're gonna pass this JSON in here. And I think that's pretty much it for the index file. So let's move on to the app.tsx file and let's start writing the application. So let's just delete this stuff in here. Okay, and now let's define some variables. So first we're gonna need a reference to our signer. Let's call it signer ref. Gonna do use ref, and it's gonna be of type panda signer. So this is imported from sCrypt.ts. Next, we're gonna need a flag that indicates if the wallet is connected. It's just standard Boolean. Let's do it like that. Is connected, and we're gonna need a set function. And we're gonna need the use state function, and by default it's gonna be false. Okay, now let's define two arrays. Since we have two tabs, one is gonna contain the items in our wallet, or rather the NFTs in our wallet, And the second one is gonna be the market tab, and that is again gonna contain the items on the marketplace. So let's write const, first one is gonna be wallet items. And initially it's gonna be just an empty array. Let's do the same for the market items. There we go. And we're also gonna need index to indicate which tab is currently selected. So let's call it active tab. And it's gonna be the first one by default. Okay, so we can go ahead and implement a function which will load the items that are currently listed on the marketplace. So let's define a synchronous function and let's call it load wallet items. Oops, it should be load market items. Market items. And since this is only a demo application, we can just use the local storage of our browser. Now in an actual application, you would probably hook this up to some publicly available database. But in this case, it will suffice. So yeah, let's define a variable which will store the JSON which we're gonna get from the local storage. So let's do local storage get item, and the key is gonna be market items. And if it will return something, we can parse the JSON. Let's call it market items and do JSON parse market items raw. Let's call it items. And then we just set it to the state variable of the React app. So we do set market items. That's it. And now let's do a similar function, but for the wallet items. So we're gonna do plot wallet items, and these won't be stored in the local storage since the ordinals in our wallet are actually on-chain. So instead, we're just gonna use an endpoint to fetch all the ordinals for our ordinal address. So let's first get the signer from our reference. Sign reference dot current, and gonna add the type to it. And if it's already there, we're gonna do a request to an endpoint. So let's just put it in a try catch statement. And in case of an error, we're gonna print an error. And in here, let's get our ordinal address from our signer. That, and I'll do signer get ord address. And I think this is some synchronous function, so we need to await it for the result. And now we're gonna query on public URL. I already had it in my clipboard, so it's gonna be Gorilla Pool has a testnet endpoint which will based on which you can get like ordinals, or rather information about your ordinals. So in this case, it's just gonna list the UTXOs or the active ordinals for our ordinal address, and it also filters out fungible tokens, since our demo application won't support fungible tokens but only NFTs. So let us fetch this URL. So we're gonna call fetch function and put in the URL. Oh, let's adjust this variable. Okay. And let's also convert it to a string actually. To string. Okay. Okay, once we have the response, we can extract the data from it. So I'll convert it to a JSON. And we want to actually filter it because we don't want to display items that are already listed in our marketplace. Let's just do data filter here. Let's do market items, and our returned items will contain the origin.out point string, and if it's already there, we're gonna filter it out. So, and let's just actually turn off the strict mode of TypeScript. So it won't give us an error about types. Okay, so once then, when we have the filtered data, we can just do set wallet items and put this in there. Okay, so we would like to run both of these functions once the application loads. So we're gonna use the use effect callback. Let's put on in a function, and let's call it load market items and also load wallet items, like that. Okay, so I think we can start defining the layout now. So let's move down. Okay, so in here, we're gonna first check if our wallet is connected. So we're gonna do is connected. Then we're gonna display one thing, and if it's not, we're gonna display the connect button. So let's put it in a div. Okay. And let's just make it centered. So we're gonna do justify content. It's gonna be center, and line items. It's gonna be center as well. And in here, we're gonna define the button. But oh, I think we're missing some dependencies. So let's just move back to the console and install them. So let's write npm install, and yeah, that's them. So it's gonna be MUI material, it's gonna be emotion react and emotion stat. So these are the three dependencies we're gonna need for our sort of stylized buttons and stuff like that. So let's just hit enter. And now let's move back to the code editor, and we should have now the button element, hopefully. Yeah, there it is. Okay, and the label is gonna be connect panda wallet, and let's add a onClick handler. So we're gonna call the function handle connect, which we're gonna define shortly, and it's gonna be a large button, so also set the size to large. Okay, let's move on to defining this function now. So let's do const handle connect, and it's gonna be a synchronous function. Okay, and in here we're gonna create first the actual signer object. So let's first get the provider, and we're gonna use the order provider, which is, it's basically just like the Gorilla Pool provider, but it has some additional stuff for ordinals. So let's define also the network, and we're gonna use testnet network. Let's first import that. Networks testnet, and now the actual signer, and it's gonna be obviously the panda signer, and put in here the provider. And now we're gonna set the reference to it, signer ref current is equal to signer. Now we're also gonna need to request authentication of the wallet, so it actually lets our app use the extension. So let's just call the signer dot request authentication function, and it's gonna return boolean if it's authenticated, and it also returns an error in case it fails. And it's not authenticated, we're just gonna throw that error further, and let's just put the error in here. Okay, and if everything goes as it should, we're just gonna set the is connected flag to true. Great, that's it for our connect. So I think this would be a great point to try running the app. Just put in here main stuff so we can see what happens. So let's go back to the console, open a new window, and do npm start. Okay, we can see that we have a button here. It sort of looks weird, we'll fix that later, but let's just click it. And it does prompt our wallet, so we put in our wallet's password in here. And hopefully, yeah, the main page loads. So I think everything is correct, except for the styling, of course. So to fix that, I think we will have to define a variant, and it's gonna be called contained. So let's save that and go back to the browser. Let's just, okay, try to reload the page, and yeah, it looks better now. Yeah, I think we should also center it horizontally, I mean vertically. So let's move back, and maybe if we try to do display flex. Okay, it's safe. Oh, okay. Try to reload it. No, it's still vertically. Let's maybe try to also define height. Let's do 100. Let's try that. Oh, okay. Now it's good. Okay, still works. Great. So now let's just go ahead and create our tabs. In here, we're gonna create a box element, and it's gonna create the tabs. And okay, and it will have two tabs. One is gonna be labeled my NFTs. Oops. It needs to be called tab. And the second one is gonna be called market. Now we need to set the value. It's gonna be the active tab variable that we defined earlier. And also we need an onChange callback function, and let's call it handle tab change. Okay, and I think we need to import this as well. And let's define this function now. Handle tab change, it's synchronous. No, it actually won't be, and it will take in an event and the tab index. Okay, so if the let's actually just set active tab. It's gonna be tab index, and before that we can also check which tab it is, and based on that just do a refresh of the data. So in the first case it will be the wallet items, and it's gonna be the second tab, it's gonna be the market items, like that. Cool. Let's take a look at how it looks now. Okay, tab is not defined. Let's just maybe refresh it. Okay, connect. Okay, we have the two tabs now. Great. Okay, so let's go back to the editor, and now we're gonna need to define how the element inside these tabs will look like and how it will be displayed. So for that, let's just create a new file, and let's call the first one item view for the wallet, and let's also create another one, and it's gonna be item view for the market.tsx. Okay, now in the view for the wallet, let's first define the interface, what it will take as parameters. So let's call it this item props, and first it's gonna be the actual item, which will contain our ordinal data stuff as the inscription image and stuff like that, and yeah, also the index of the element, and also reference to the callback function of the button it will contain, and it will contain a list button which will be used to list the items on the marketplace. So let's call it onList. It's gonna be a function which won't return anything, but it will take in the index of the elements and also the price of the listing. Let's call it price satoshis. It's also gonna be a number. Okay, now for the actual element, let's do const item view wallet, And let's import React. It's gonna be FC, and gonna take in this custom item properties. Okay, so in here we define the function. So it's gonna take in the properties, which is an object, and it contains the item, the index, and the callback function. Okay, and now for the function's body, let's return the actual elements. Okay, so this is gonna be a card item, card, and this will contain a card content. And our app will be able to handle ordinals with either image inscriptions or text inscriptions. So we need to handle that here as well. So let's do on condition here. So first one, if it's gonna be an image, we need to display an image. So we first check the MIME type of the item. So for that, we're gonna do item dot origin dot data dot inscription and file type. And if it starts with image, then we can display the image. And for this, we can use a regular image element, image, and the source of it is gonna be, we're gonna query the Gorilla Pool endpoint again, but this time we're gonna need different URL. So I already have it prepared here, so let me just paste it in here. Okay, so as you can see, it's gonna query the Gorilla Pool endpoint again, but this time we're gonna need the content of the inscription. And for that, we pass in the out point of the origin of the item. Okay, and I think that's pretty much it for the image part. Now let's just also handle text inscriptions. So for that, again, we're gonna check the MIME type. So let's just create a copy of this here, but here instead, if it starts with image, we're gonna check if it's equal to text slash plain. And for this, we cannot use the image tag, but instead we have to have a variable with the actual content which we can display. So let's just create a typography element here, and yeah, let's stylize it as h5, and it's gonna be a div. Okay, and in here we're gonna display, if it's already fetched, we're gonna display the text, let's call it text data, or if it's not, we're gonna use a placeholder and it's gonna display a message that it's still loading the text. Now first, let's just define this variable. So again, we're gonna use text data, and we're gonna need a setter, set text data, and it's gonna be use state, and it can be either a string or a null value, and by default it's gonna be just null. And we're gonna set the value of this variable once we get the items. So I'm gonna use the use effect callback again, find the function, Oops. All right, item. And we're gonna use that only if it's a text item. So let's just do this check here again. If it's a text item, then we fetch the actual content of it, of the ordinal. And again, we can use this the same URL that we used for the image. So let's just take this, paste it in here. Yeah, and let's fetch this URL now. Fetch URL, and if it fetches, we're gonna get a response. And we're gonna extract it as text, since it's text only, not JSON. After that, we can just simply get this data, the raw textual data, and set it in the variable itself. And in case of an error, yeah, we can just print an error for now. Yeah. Okay. So maybe now check if it already displays something. Okay, it seems like it complains because we didn't export this element. So let's just do export default item view wallet. I think that should fix it. And of course do the same for the market. Yeah, let's just actually delete this for now. So let's go back to refresh. Okay, seems like no error now. Try to unlock the wallet. Oh, and of course it doesn't display anything for now, since we don't display this item view wallet elements in here. So we gotta define that as well. So here, let's just check if the active tab is the first one, meaning it's our wallet tab. Gonna display an element, and this element is just gonna be a box. And in here, for each wallet element, wallet item that we have, we're just gonna display a separate item view element. So it's gonna be item and the index. And in here, we're gonna return the item view wallet, and the key is gonna be the index. Then we're gonna pass the item, the index, and also the on list. Let's just call it handle list. We don't have it defined yet, but we will do so shortly. Yeah, okay. I think that should be it for that. So let's do this. And called it handle list. And it's just gonna take in the index, and it's gonna be an asynchronous function. Okay. I think that should be enough. So let us check the actual application. Okay, it seems like it actually displays the contents now, even the text ones, but they're way too big, so let's try to make them a bit smaller. So let's go here and make the card itself smaller. So let's just do style and make them maybe even fixed size. $400. Add a margin. And for the image, we're gonna also cap it with a maximum width. Max width of 250. Okay. So let's check now. Yeah, that's much better. Maybe let's also make them appear side by side. So let's go back to app.tsx and here let's stylize this box. I think we need to use the SX display flex. And it's gonna be centered as well. Center. Okay, let's see how it looks now. Okay, great. I think this is good enough already. So what's still missing is maybe we should also, display an inscription ID here and also put in the list button, and that will in turn also display a text box which takes in the price. So let's do that now. Let's go back to the editor, to the item view source file. Now first the inscription ID. So that's gonna be item.origin.num, and if we're gonna have that value, then it also display a typography, and it's gonna be body 2 since we want to make the text a bit smaller, and it's gonna be grayed out secondary. Okay, and here let's do a pound sign and display the actual value. And we're not gonna have this value, let's just display, instead of the value, let's display pending. Now that will probably display often, especially if the ordinal was just recently moved to your wallet, because you get this number only once it's mined in a block. Right, now for the list button, let's just do a button element, and it's gonna be contained, and it's also gonna take in the click handler. And actually this isn't gonna be the actual listing handler, but it's gonna be an intermediary one which will display a text box for the price. So let's call it handle list for sale. And okay, let's define this function, handle list for sale. Now this function is gonna be called in both cases if it's either to prompt the text box or the actual confirmation. So we need a Boolean value to handle that. So let's just add one. It's gonna be called is listing, and also the setter set is listing, and it's gonna be a Boolean type, and it's gonna be false by default. Listing. Okay, so in here we're gonna check if this is set. If it's not, we're just gonna set it. Set is listing to true. And if it is listing, then well, we'll have a price string, which we're gonna set via a text box. Set price, and it's gonna be string. It's gonna be empty by default. And in here, it's just, since it's gonna be a floating point number, let's just parse it from a string. So let's call parse float price. And if it's not, it won't fail. And it will be larger than the minimum amount, which is 100 million of a Bitcoin. It's gonna be 7 zeros, I think, and a 1. 1, 2, 3, 4, 5, 6, 7, and a 1. Okay. Oops. Float. Now if it doesn't fit that, we're just gonna print an error. Invalid price entered. But if it is correct, then we need to parse this into the actual satoshis, which is gonna be just an integer. And price float, and we're gonna multiply it by 100 million, which is 10 to the power of the 8. And in here, oops, now we can actually call the onList handler, which will update, which will actually deploy the ordinal lock smart contract, which we'll implement later. It's gonna take in the price in satoshis. Okay, and once that is done, we can just set this boolean back to false and set the price back to an empty string. I think that should be enough for this function. Yeah, now we only need to add this actual text input field. Let's just first make this button display a label. So if the isListing flag is set, then we're gonna display confirm. If not, we're gonna display list for sale. Okay, so now if it is listing, then we're gonna display this text input text box. So that's a text field element. Okay. Gonna take in a bunch of stuff. First, the label. Label is gonna be set price, and it's in BSV. Variant. Let's make it outlined to look pretty. The value is gonna be the price string. Then we need an onChange callback, and it's just gonna be a simple anonymous function. Oops. And it's just gonna set the price, nothing else. Target value. Okay. The type is gonna be a number. Let's just add a default value as well. So input properties step, by default it's gonna be 0, 0, 1. Let's say that. Okay. Let's read that. All right, so let's see how that looks like. Okay, we got the list for sale button now. So if we also the inscription number, and if we hit one, for example, a text box should appear. Okay, we need to sort out the margins, I guess, since it's a bit overlap, but yeah, it's by default 001. And yeah, that's pretty much it for now, I think. Let's move back. Yeah, maybe set a margin here. So let's style margin top 10. Yeah, I think that should make it a bit better. Yeah, okay. All right, so I think we can move on then to implement this handle list function. And what this will do is it will create an instance of an ordinal lock and actually lock the ordinal inside of that. Okay, so I think this should also take in the price in Satoshis. Set number. And do we pass it to the item view? Yeah, handle list. Okay, that's fine. All right, so good. Now in here, let's get the signer from the reference, current as panda signer. And let's get the item, so wallet items, and since we have the index, we can get it by that. And yeah, then from this item we can get out the out point. This is just the current, the most recent iteration of the ordinal, the UTXO out point. All right, so now we can probably get the actual UTXO from on-chain. So let's just define a variable UTXO. It's gonna be of type UTXO. And we're gonna use the onSet APIs object to and use the fetch UTXO by outpoint function, and it's gonna take in the outpoint string. Yeah, so in here just pass in the outpoint, and I think we also, for the onSet API, we need to set the network. So I think by default it's set to mainnet, so let's just set it to testnet. Okay. I don't know why that is popping up. Okay. Let's import. Okay, so I think that should get our UTXO. So here, since by default our ordinal is gonna be locked in a regular pay-to-public key hash, we can do fetch an object which will contain that. And yeah, it's by default represented by inside the sCrypt ord package by ordi NFT pay-to-public key hash. So this is just sort of a standard smart contract that's used to represent an ordinal NFT inside our code to make it easier for us. So we can do that instantiated just like a regular smart contract from a UTXO, and that will be our instance. And now that we got this instance, we can create the instance of the subsequent ordinal lock contract that is gonna unlock this smart contract, or this UTXO rather. So we're gonna say const, I'm gonna call it ord lock, and it's gonna be new ordinal lock. And this takes in the seller's public key and the amount of the sale. So let's just get this. And since the seller is gonna be us, we need to get our ordinal pub key from our signer. So we're gonna do signer get ordinal pub key. And it's important to use the ordinal pub key and not the default pub key, since the Panda wallet actually has two public keys. One is for payments and the other one is for ordinals. So it's important to use the ordinal address or pub key in this example. So let's turn this into a pub key element, to a byte string. So ord pub key to byte string. And now also get the amount, and since it's a number by default, we gotta convert it to a big integer, since sCrypt smart contracts work with big integers. And I think that's already ready, so let's pass it in. And we also wanna connect our signer to the instance. Connect signer. Okay, I think this is already ready to be used now. So again, this, or rather this, is representing the actual ordinal that's already on chain in our wallet, and this instance is gonna represent the next iteration, which is an ordinal lock. Now this ordinal lock again can be unlocked by someone who pays the price that you ask for it, or it can be aborted and cancelled and it will return as a regular pay to public key hash output in your wallet. So now let's unlock this already deployed ordinal output. So let's just also connect it to signer, and we're gonna do await, and we're gonna call its public method. So it's gonna contain a single one. It's unlock, and because it's a regular pay to public key hash, we need to pass in a signature. So we do that by callback and find sig from the signature responses, and it's gonna be the signature of our ordinal pub key, and also the pub key itself. And then we're also gonna pass in the method call parameters. Just make it a type. It's of type ordi method call options of the ordi NFT pay to public key hash contract. And what we need to pass in here is gonna be transfer property, which is gonna be the instance of the ordinal lock, which we already created locally here, and also the public key that's gonna be key or address to sign. It's gonna take in the ordinal pub key. Okay, and this will then return a transaction of the call transaction. So transfer transaction. Okay. And we can just log transaction ID here. Transferred NFT. And let's put in here transfer transaction.id. And yeah, what we have to do now is store this instance or this item that we created for the market in our local storage, like we used before to load. Now we need to store it. And since we don't have a function for that yet, we should write one. And here, where we have the load market items, we can start defining it. So let's just call it store market item. It's gonna be also it's gonna take in the transaction or the log transaction, which we just created by the contract call. So this is gonna be a BSV transaction. It's gonna take in the price of the listing, which is a number, the seller's public key. Let's make it a string in this case, and the item itself. Okay. So let's load the market items that we already have, if we already have them. Market items, and use local storage get item. It's gonna be the keys market items, and if it's empty, then we can just create an empty object for now. And if it's not, we're gonna reuse them. And yeah, let's parse them. JSON parse market items. Okay. And yeah, let's make it any type. Yeah, let's just make these indexed by the ordinals origin. So let's do market items item.origin.out point, and store an object in here, and we're gonna need the transaction ID. So it's gonna be of the log itself, right? And the index of the output, which should be 0 by default, and price, and then the item itself. And I think that should suffice for now. And now let's store it again. Local storage, set item, market items, and we're gonna convert it back to a string. So we're gonna use the stringify function of the JSON module and put this in here. And that should be it. And now maybe also update the React variable for the market items, so we have it ready to use. Okay, I think that should be it for the store function. So now let's just move down where we deployed the ordinal lock, and let's make it store it right away. So store market item, it's gonna be taking the transfer transaction. It's gonna take in the price, seller, and item. Yeah, price. Oh, price sets, of course. Okay, so actually, let's just try to deploy an ordinal lock now. Let's unlock the wallet. Okay, now open the console and maybe try to list the first one. Put in a price. Let's make one more 0. Okay, put in our wallet's password again. And hopefully here we have it. So that's the transaction ID. Now we can go to a block explorer. Put it in here. And that's it. That's the deployed ordinal lock. And this will carry the ordinal of an NFT and put the appropriate locking conditions on it. All right, so I think we can move on to implement the item views for the market right now, because now it should display it, but it doesn't yet, right? It already correctly, disappeared here, but it still needs to be displayed on the marketplace right now. And yeah, so let's go back to the code editor. And yeah, just because I noticed that the wallet items don't load right away on a refresh, let's just, in the handle connect, let's just also load the wallet items just to avoid the blank page. Okay, so now let's create another file here, item view market.tsx, and now let's just copy all of this in here. And now we need to adjust everything. So yeah, it will take in market item from our local storage and the index of the element. And we're gonna have two functions now on buy. And since the price is already known, it will only take in the index, and also the on cancel. And since we need to differentiate if we're, if it's us selling the item or not, we need also a Boolean value to indicate that. So let's call it is my listing, and it's gonna be a Boolean. Okay, let's rename this to market, and it's gonna take in these items: market item, index is my listing, on buy, and on cancel. And now in here, I think we don't need these two. We're gonna need to display the actual data again of the inscription. Let's call this market item. This is gonna be pretty much the same. So we wanna display the image or the text. Let's remove this one for now. Okay, rename here as well, market item, and we're also gonna keep the inscription number. And we aren't gonna need these two, so we can delete them. Oops. And let's also display the price of the ordinal. So let's do price. And I think this should already contain it since we stored it before. So it's price And since it's in Satoshis by default, we need to divide it by 100 million BSV. Okay, so now we need to decide if it's our listing, then we're gonna display a button labeled cancel. And if it's not, it's gonna be the buy button. So let's just define the first one. So this is gonna be the cancel one. Button. And let's put in a click handler. It's gonna call on cancel. And yeah, let's put in the market item. Yeah, let's label it cancel. And the second one is gonna be pretty much the same, but it will call the onBuy function, and the label is gonna be buy. And I think we also put an index here and just make it item. Let's maybe call it market item. Good item. Yeah. Let's just also fix this. And now I think that should be mostly it. No, there's still an error somewhere here. Oh, I didn't adjust these. Market item. Market item. Okay. So now let's move back to the app.tsx and make these display. So we're just gonna copy this, but we're gonna make it for tab number 1. And this should be the same, but here, instead of wallet items, we will loop over market items, and this is gonna be item view market. This is gonna be the same. Oh, we need to also import it. Oops. Okay. This is gonna be adjusted to market item, the index. Here we're gonna do the two functions on buy. Let's call it handle buy, and a similar one for the cancel event. Cancel, handle cancel. And let's just put these two, let's define them, copy this. So handle buy, and obviously it takes in the market item, and do the same for the cancel. Cancel. All right. Oh, right. Yeah, we also need to decide if it's our listing, right? So is my listing, and for that we're gonna check if the let's just call it this value, and it's gonna be actually value.item, and in here we can get the owner field, and we check if it's yeah, we also need to store our ordinal address into a variable, so let's just go ahead and define that. Let's go all the way up, and in here I'll do connected or ordinal address. Also rename this set connected or the address, and it's gonna be undefined by default, and we're gonna set this in the connect function. So handle connect. Here we can, once it's authenticated, we can get the or the address from the signer get ordinal address, and yeah, we can store that here, set connected or the address. That should be it. And now here we can do the check connected or the address to string. Yeah, and now pass it in here. So I think it's the third, yeah, is my listing, and we're gonna pass that value in here. I think the error should go away now. Okay, cool. So now if we go back to the app and unlock the wallet. Oh, okay. Oh, right, because this is an object and we need to loop through the values of an object, not an array. We need to do object entries, pass in the market items in here, and now we can map over that. Yeah, and this needs to be an array, and key value and the index, like that. Okay, now let's unlock it again. Oh yeah, it actually appears now, and we have the cancel button. Now it still errors for the price, which we're gonna check out right now. Yeah, okay, let's go back to the editor, to the market item view, and okay, I think I know what the problem is. So instead of passing in value.item, we pass in the whole value and do item here for each of these. So we're gonna do item.origin and adjust all of these. Yeah, this one as well. It would be probably quicker with the substitution, but we're pretty much done. Yeah, and now this should actually display the item, so let's save and check. Yeah, let's close the console. Yeah, okay, now it displays correctly, so great. So I think we can move on to implementing the cancel functionality right now. So let's go back to app.tsx and go to the handle cancel function. And in here, we're gonna get the signer again. Let's just copy this Okay. And using the provider of this signer. So let's just first connect this signer so it won't throw an error. And now we're gonna fetch the transaction of the deployed ordinal lock. So we're gonna do await signer and the provider, and we're gonna call get transaction. And in here, because we have the market item, we can just fetch the transaction ID from that, and that will give us the raw transaction of the deployed contract, and from that we can instantiate the contract object, the instance. Let's call it ordinal lock from transaction and pass the transaction in here, and also the output index, which is the first output. Okay, now we actually have the instance here locally, so let's just connect the signer to this instance. Signer. And I think we're already ready to call the cancel public method of the contract here. So let's just do call result equals await instance methods, and it's called cancel. And it's gonna take in, we can take a look at the definition. So it takes in just a signature as a parameter. So we're gonna do sig responses, and we're gonna find the correct signature. And yeah, we're gonna assign this with our ordinal public key, connected ordinal. Oh, that's the address. So seller public key. We're gonna fetch it from the signer dot get ord public key, and yeah, pass this in here. And now the method call parameters. I'm gonna set the type. Ordinal lock. And we're just gonna pass the public key with the private key, of which we're gonna create the signature. And that should be mostly it. So now we can display the transaction ID in the console. We're gonna do cancel call and just do call results dot transaction dot ID. And what else? Oh, right, we need to also remove from the local storage this entry of the market listing. So for that, again, we don't have a function yet. Let me just out of this. So yeah, here we have the store, and now we also need a remove function. So let's call it function. So let's call it remove market item, and as an input it will take the index, which is just the origin out point, which is a string. And here we're gonna just take this stuff to retrieve the existing entry if it exists. And now let's just maybe also copy this, and instead of setting information we'll just set it as undefined. Yeah, and in here, instead of this, we can just do origin out point. And I think that should be pretty much it for this function. So let's go back to the cancel callback function and move the market item here. And we're gonna pass the market item origin and the out points. Okay, so maybe let's try to hit the cancel button from our application. So unlock the wallet, go to market and hit this cancel. Let's also open the console maybe. Cancel. Yeah, let's retry. Okay. Put in our password. Hit enter. So it seems like the cancel call was actually successful. So let's just check the block explorer. Yeah, okay, that went through, but we have an error and it says cannot read properties of undefined item. Okay, so let us check out that. So let's go to line 204. Yeah, okay. So, oh, right, because we set this like this, we still have the key and it shows up there. So instead, we could simply do, actually, instead of setting this to undefined, we can delete the key itself using the delete keyword, and that should fix it. Now it's still in the local storage, I think. So let us maybe also clear that application and just clear this. Yeah, it's empty now anyway. Clear. Yeah, okay. Great. Now it seems like our item is already back here. Now, sometimes when you do these actions, it might take a while to get picked up by an ordinal indexer. So it's maybe if you buy an item in the marketplace, it takes a few minutes to actually show up in your wallet. So keep that in mind as well. Okay, so now the last thing that remains is implementing a buy button and functionality as well. So let's just maybe, for an example, already list this beforehand. Let's just pick one, put in a price. Okay, to confirm. Okay, put in our password. Okay, cool. And now, yeah, it appeared here, disappeared here. Cool. Now we already have it listed. Now, since we're logged in our wallet, right, it will show the cancel, but if we later on we will switch wallets and it should display the buy button since it's not our listing. But first, let's move on to implement the actual functionality of it. So go down in app.tsx to the handle buy function. So it's gonna be pretty similar as the cancel function. So let's copy the contents of that one here. Again, we construct the ordinal lock instance locally, get the public key, and now in here, instead of the cancel method, we call the unlock method. And it's actually called purchase. So let's adjust. And what it takes in is just the address of the receiver. And Obviously the method just makes sure that the seller gets paid the appropriate amount, which will be handled already by our wallet automatically. So in here we just wanna receive the address of the receiver, or by that I mean the address where the ordinal is going to. So that's gonna be the buyer's ordinal address. So buyer public key is gonna be all wallets ordinal public key, and in this case the seller public key, we're gonna parse it out of the instance. So instance seller. Okay, so the receiver address is gonna be buyer public key to address and we're gonna convert it right away to a byte string and wrap it inside the address decorator. Okay, yeah, let's import it as well. And in here, yeah, we're gonna just paste in the receiver address, and I don't think we need anything else. Just this is a purchase call, and display the transaction ID, and again remove the market item since it's been bought and it's not listed anymore. Yeah, I think that should be it actually. Yeah, apparently we don't even need that, so we can just remove that, hit save. Now we can move back to the browser, and since we're logged in with our initial wallet, let's just open the Panda wallet extension, go to settings and sign out. Yeah, and we're gonna create a new wallet. This time put in a password to generate some keys for us. That's fine. Yeah, switch it back to testnet mode, that's important. And let's give it some fonts. So let's copy our address, go on to sCrypt.io/faucet, get some testnet coins free. Okay, let's move back. Yeah, it should receive it shortly. Yeah, it's already there. Cool. Now, obviously, initially we're not gonna have any NFTs in here. So if we refresh the application and connect it again, it won't show anything since it's empty. But in the market, since it's the same browser, it's the same local storage, it will still have the listed item. And now instead of the cancel button, we can see the buy button. So let's just actually try to run that, see what happens. Okay, it prompts us for password, put in here. And hopefully that will unlock the actual transaction. Yeah, so we got a transaction ID, we can check it on chain if we want. Cool. Yeah. So now again, it will take a few minutes usually after a buy to show up. So let's just skip forward a few minutes and see if it actually appears in our wallet. Okay, so now after a few minutes have passed, and lo and behold, it actually appeared in our wallet, and we can also double check in here, and here it is. Right, so we successfully bought it, and our first wallet got paid for it, and we got the NFT in return. So that's great. So I think this is a good point to end our tutorial. So hopefully this video made it more clear as to how Ordinals can cooperate with sCrypt smart contracts. So if you're interested in learning more of how it works, I recommend going to the official sCrypt docs, and in here we got a new section called tokens, and it basically described what I just described in the video, but also for stuff like fungible tokens and different situations in how we want to make sCrypt interact with ordinals and stuff like that. So definitely check that out and stay tuned for upcoming videos. And until then, have fun coding. Goodbye.